All right, it is now 2 minutes past starting time, so we are going to get going. Today's session is all about the token SDK on Corda. So I'm joined by my colleague Anthony Nixon, who will be doing half the presentation with me, and we're both members of the developer relations team at R3. We're going to start with a very brief overview just to freshen your knowledge about what a Corda app is. Then we're going to go into the details of how we've implemented tokens in Corda and what token types are available to you. And then finally, we're going to dive into the code to give you a bit of an idea how to use this yourself. If you have any questions, feel free to put it in the chat and we'll get back to you either in the chat itself or in the session. So with that, let's get started. So a quick recap of what a Corda app is. Now, if you've done one of our bootcamps or you've gone through the getting started materials for Corda, you're probably pretty familiar with this. But basically, when we talk about a Corda app, there are three components involved. The first is the state. And the state is what we call the object that is being transferred between the different parties that are doing transactions with each other. And that state is then stored in the ledger for both parties that are involved in that transaction. So in a way, you could think of a state as being a database row with a whole bunch of fields that are unique to that one transaction. The second part is a contract. Now, a contract is a bit of code that is evoked every time that a state gets transferred. And in that contract, you can verify to make sure that whatever is in that state is valid based on the business rules that are applicable for you. For instance, if you want to implement a Corda app where you can transfer money between parties, you probably want to make sure that the amount of money that you're transferring between parties is more than zero, because if it was a negative, then you could take money from someone. And that's probably not what you're intending to do, right? So a contract allows you to verify all the fields in the state to make sure that they match up to your business rules expectations. Finally, the most important part in Corda is the flow. The flow is what we call the communication between the different parties on a network. So when party A connects to party B to say, I would like to get a state from you or an asset, or I would like to give something to you, then that connection between the two and the whole communication between the two is called a flow. Now, in a flow is generally where you would put all your basic business logic, you construct your transaction there, you get information from external sources or oracles if that's something that's part of your implementation. And all the communication, the signatures, the verification, all that heavy lifting happens in the flow. Now, one of the nice things about Corda is that all that logic that does the encryption, the security, the identity checking, the signatures, and everything else is already built into the toolbox. So all you have to do is build a transaction that has a state in it and then trigger the flow on your own end, which will then communicate with the destination party. So with that out of the way, let's get started on tokens. Now, the basic concept of a token is something that we're all familiar with in one way or another. One of the examples that we often use for what a token looks like in the real world is when you leave your coat. When you go to a club or a movie or a restaurant where there's a coat check, you will probably get some form of token. It could be a bit of paper that they staple to your jacket. It could be anything else that they give you that allows you to return to the coat check afterwards and say, I would like to claim my jacket. And the number on that token, it identifies the jacket that belongs to you, right? Without that, you would have a much harder time to get your jacket back. So that little ticket is your token. Now, tokens, of course, in the real world could be anything. It could also be a certificate of a stock that you purchased. It could be a deed to a house. All these things, in a way, are tokens, right? So digital tokens in Corda are a digital representation of the same concept. It is a bit of paper, digitally in this case, that represents a connection to an object. And that could be a real world object or a digital object. Now, one of the versions of tokens that most people are already familiar with is cryptocurrencies. So if you're looking at like Ethereum or Bitcoin or any of those kind of things, then those are tokens. But that is only a small subset of what you can do with tokens. Like representing a crypto asset is only one form of representation. You could, for instance, also represent an ownership of a house with a token or any other kind of asset, right? So a tokenized asset is the digital co-check ticket that represents a thing that you can trade and send and redeem over a digital network with other partners in that network. So tokens on Corda, the first thing that we need to get out of the way is that it is not in itself a cryptocurrency. Theoretically, you could try to build something like that using the token SDK, but it is not what the token SDK is. A token SDK is a flexible implementation that allows you to represent ownership of any kind of asset, real world or digital, within Corda. It is indeed a bearer instrument that represents liability between the issuer, the one who created the token, and the owner, the person that the token has been transferred to. Now, because all of this is implemented on Corda and uses the whole framework of states, contracts, and flows, you get all the security benefits that come with Corda. So all the security provided by cryptography, by distributed ledger storage, where every transaction in the chain can be checked, all the double spend prevention, and all the other mechanisms that provide security in Corda are part of the token implementation on top of Corda. You also get simple traceability. Whenever you're doing a transaction of a token, the history of that token is represented in the chain, in the history, the transaction history. And that can be easily looked up in your databases. And that means that you can always go back to the roots of a token issue and see where it came from. And if that is a party you trust, you can see all the transfers that happen in the meantime and get a full, credible, verifiable history of any assets that you're transferring. Finally, one of the benefits is that it increases liquidity and market access. Now, for anyone, excuse me, anyone who is not in the finance sector probably looks at these words, increase liquidity and market access, and goes, what the heck are you talking about, Chris? What this means in human language is that imagine that you are a bank or an investor and you would like to use something in a different country as something to guarantee you're underwriting a contract or a loan or any kind of financial capital market transaction. Imagine that it's an artwork that is not allowed to leave the country or a house that you can't necessarily move across borders, right? You couldn't necessarily use that contract from a different country that shows that you own a house to do something in your own country. However, if you represent the value of that house and the ownership of that house as a digital token, it can now suddenly be used on your Corda network to represent the value of it without actually having to move the local guarantees and deeds in the different country that the house is located in. So this means that there's a whole category of things that previously couldn't be used in financial transactions that suddenly can be used in financial transactions. And that's pretty exciting. So with that out of the way, you got a bit of a basic idea, I hope, about what a token is and what we're talking about in this Token SDK workshop. So with that out of the way, we'd like to give you a bit of an overview of what the Token SDK is, talk about fixed versus evolvable token types, fungible and non-fungible token types, and how tokens are managed in the lifecycle. Now, I'll give you a brief overview here. After I'm done with that, we'll switch to Anthony Nixon, who will show you what this looks like in code in his IDE. So anything in Corda can be created, issued, moved, and redeemed. That is the standard flow for many of the things in many of the states that are created on the Corda chain. So when you're implementing a flow, you probably have different flows for all these different actions. something that can move assets between different people, something that can issue and create assets. And sometimes you want to redeem assets, which means I'm converting this back into a real world object again. Or it could mean I have used up whatever this thing currently represents. So the token SDK provides a library that does all of these things for you. So initially, when your node is running, there are no tokens, right? When you're starting the application for the first time. So you need to create an underlying token type, something that represents an asset that you want to be able to use in your Corda flows and transacting between people. So that's the create step. The issue step means that you're giving that token that you've just created a representation of a digital real world asset, and you want to give it to one or more people. Those are the owners, the initial owners of that token. Now, of course, those people or that person need to be able to do something with that token. You need to be able to give it to someone else, for instance, if you're selling it or trading it for something else. So that is what the move function does for you. And finally, the redeem, as I mentioned earlier, means I have used up or destroyed the thing that this token represents, and that token is no longer valid. The detail I'll add to that is that the representation will always remain in the database. So the history of that thing that is invalid will always be saved, but it will be marked as invalid and it can't be used for future transactions anymore. So if you look at the types of tokens in the token SDK, the base types are either fixed tokens or evolvable tokens. And let's take a look at what that means. So if we look at fixed tokens, then we have a tokenizable asset info, which describes the thing that it is. There's a token type, and a token pointer points to that thing that exists, and that is unique. An evolvable token type, on the other hand, is based on a linear state. And a linear state in Corda means that you've got one state and you can create new versions of it over time. Now, you might ask yourself, like, why would I use a fixed token type versus an evolvable token type, right? So a fixed token type is a representation that cannot change over time. And that's what we mean by fixed. For instance, if you have a token that represents $1 American, that will remain $1 American. The actual value of that doesn't change. It is still $1 American. On the other hand, it might be that you're representing something like a car. Now, there are a number of attributes to a car that are fixed. For instance, the maker of the car, the brands, the model number, the serial number, those are all things that are pretty fixed, right? And generally speaking, an evolvable token, you would check that those things are unchanged over time in the contract that I mentioned earlier. However, things like mileage, a number of repairs that happens, your registration with the DMV or your local version of that, the value of the car, all those things are changeable and change over time. So you want to be able to represent that and evolve the token over time to update it to represent that object as best as possible. So that is the difference between a fixed token, an unchangeable thing, and an evolvable token where things can change over time. So the basic classes for these are in the Corda core, the linear state, the contract state, etc. The token SDK is the thing that provides the implementations for the token type, the token pointer, and the evolvable token type. So finally, we also mentioned fungible versus non-fungible tokens. So fungible tokens are things that can be split up between different people. The graphic that we're using here is, imagine that you have a bill for 2,000 of a currency. You could split that up in 400 or 500 bills, right? Tokens can be like that. Fungible tokens are made to be like that. You can have one token and then in a transaction, in a flow, break that up in multiple things. For instance, you could send half of it to someone else and keep half of it for yourself. Now you have two tokens that came from the one token representation. Or imagine that you're transferring something to 6 people, then you would split your token up in 6 bits. Because of Corda's model that prevents double spend using notaries and all those things you've seen in your getting started material, it prevents these things from being double spent. So these new representations are unique new inputs for the following transactions, and you can't use what came before. Now, the non-fungible tokens are things that are not splittable. For instance, a house can change over time. We talked about that with the fixed and the non-fixed. The evolvable token type, the value of it can change, but you can't split a house up in multiple parts. Like that will be very messy and take a lot of construction, and it's safe to assume that that's not something that we do, right? Likewise, if you look at objects like a bit of art or a car or anything, those are not things that you can split up into multiple pieces. So those are non-fungible. That doesn't mean they can't have multiple owners, but it will be one house, so one house token that has multiple owners in the state. That's how you would represent that. You wouldn't be able to take a house token and split it into two house tokens with each one owner. I hope that makes sense. So with that, I'd like to, and they both come from an abstract token. And with that, I'd like to hand this over to Anthony, who will now dive into the code representation of this.
Hi, everybody. I'm Anthony. I will be doing the practical part of what Chris just explained. So as I share my screen here, you will see two different representations on my screen in a different format than Chris just described, but representing the same thing. So I'm going to go through the implementation deals of how you go from a base token type, whether it be a fixed token or an evolvable token, all the way up to issuing it through these various layers of abstraction, ending with your fungible token or your non-fungible token. So on the graphic on the left here, what we have is a fixed token type. So this would be representing anything such as a currency, like a cryptocurrency, if you wanted to implement such on the Corda network, anything where the actual representation will not change. So if you have a US dollar, obviously the US dollar has something like a decimal value. You can go up to cents. But beyond that, it will never actually change. It doesn't have an associated property related to wear or related to an ongoing evolution, such as a maintenance, etc. So that's what we want to represent as a fixed token with the base token type. On the right here, what we have is a representation of an evolvable token. So here, this is a car token type representing some ownership or holding of a car. So here we're having properties which will change over time and affect sort of like either the value or the interaction with this object. So we wrap it into an evolvable token type and are able to issue that. Now, the thing that I want to point out is whether you go with a fungible token or a non-fungible token is up to you. It is not something that is tied to the particular token type or definition. So here on the right, you notice that with a car token type, we're using non-fungible. This is because of the fact that in the general real world, generally there's one owner of a car, and this will not be split or merged at different time periods. But you could easily take an evolvable token asset and decide to represent that in a staking or ownership sense. And in that case, you could create your base token type of evolvable token, create the car token type, add an amount to it after you issue it. So the only thing that's different between the left and right diagrams is the fungible token requires an amount. So by adding an amount, you could say that this particular evolvable token is allowed to be held by multiple parties through splits and merges. So with that being said, let's go right into the code so I can give you real examples of this. So I'm using one of the samples from our samples repository online. Let me type in the URL so you can grab these later, and it'll be pasted on a slide at the end of our webinar here. So first, I'm going to go through a simple house token creation and a fixed token of a certain currency, which in this sample is used to do a swap. So we'll get an example of both types of token, whether that's fixed or evolvable, and then we can see and discuss the differences between them. So the first thing I'm going to do is I'm going to basically go over the structure of this sample so that you can dive into it yourself when you have time or after the session. Like any modern CorDapp, we have two different modules generally, one representing states and contracts, and then the other representing workflows or Corda flows. And this was related to the first thing that Chris was talking about in the introduction. So here I have on the tree on the left, I have a house state and house contract. I'll talk about that in a second after the currency. And then here in the workflows module, I've got the different operations or business processes that I want to do. And here is where I'll actually be implementing the logic to formulate those abstractions or formulate those constructions that I just showed, these particular ones. So I'll show analogously how each of these is built up. This here is the fixed currency issue flow. So it's a regular Corda flow, which will be instantiated and executed at the call entry point. Now here's where the action begins and things start to get interesting. The first line that you see here is this creation. So remember that Chris talked about the 4 stages of token implementation. We have creation, we have issuance, we have movements, and we have redemption. So these are the different operations. And what the Tokens SDK does is it provides very streamlined and simplified APIs that handle all of these operations easily for you. So they abstract away the complexity. So what we're doing here is we're creating an instance of a base token type. This is actually calling a subfunction, so I'll jump right down to it. And this is basically taking in the parameter that we received on what currency we want to use or issue for this fiat. This could be US dollars, Great British pounds, euros, etc. Now I'm quickly going to jump into this helper function. With the Tokens SDK, you have helper utilities such as money utilities, which will allow you to instantly and quickly grab certain token types, certain amounts, certain things that you need to use while building your particular use case or your token. So this money utilities is actually just streamlining something which is very simple. So behind this, it goes into the money utilities and it ends up at this, this function right here, which is getting an instance of that currency code. Now, if you look at what you're getting back, this is how we created or instantiate it. A fixed token type or a base token type takes in 2 arguments, which is a currency code or a descriptor, and then a fractional digit. The fractional digit meaning like this particular token type, what are the allowable ranges of split and merged? If you're talking about a US dollar or a general fiat, usually that's a fractional digit of 2. So you're going down to the 100th, right? So by calling this, what I'm actually getting is a token type, but I could create any arbitrary token type myself if I wanted to call I wanted to create something like an Anthony token type. So if I wanted to create an Anthony token type, I could do new token type and then pass in my identifier, which is like Anthony's token. And then I could say, well, what are the particular values or what are the fractions that this is going to be able to be split and merged in? So if I wanted to do something like a standard currency, I could put 2, but you could arbitrarily decide on this sort of like resolution or how fine-grained your token wants to be. So this is how I would create a fixed token. Now, you notice that there's only 2 properties here. There's basically a descriptor and that fungible fractional representation. But this can also represent more complex objects or digital assets with additional properties. And you could simply do that by extending the token type class. So I can extend on this and add properties that will never change, such as like my birthday, such as maybe like, I don't know, my favorite color, assuming that never changes. It hasn't changed in however many years I've been alive, so that's possible. So this is that first stage of creation. And now we have all these additional things, such as adding an amount, also issuing, and then actually deciding, is this going to be fungible or non-fungible? So with this, we have a new utility, which has been available since Tokens SDK 1.2, and that's called token builders. So we have both the fungible and non-fungible representation of a token builder, which streamlines the process that we illustrated before. So it's going to be taking this A, B, C, D, or A, B, C if you're using a non-fungible token, and it's going to allow you to kind of just append or build this token up from scratch. So what I'm doing here is I'm instantiating a fungible token builder. I'm passing in my token type, creating an amount. So how many of this particular token will I be issuing? I'm going to put in the issuer's identity, which is our identity in this case. It could be another issuer, etc. If you made a flow that built it on your end and allowed a signing party to be the official issuer through a signature. And then I'm going to put in the current holder or the recipient. Then finally, using the build fungible token function, I will get back a fungible token. So now we have this whole thing where we have a definition and we have a token ready to be issued. And now the tokens SDK will allow us to call a subflow called issue tokens, which will streamline the process of actually taking all those tokens and then sending them to a recipient along with the definition and the ability for them to capture that state on Ledger. So this is all sort of like synchronous, and you can kind of see the evolution of how this is put together. Now, this is the fixed token. So this is, I would say, the simpler case and something that many people want to do if they want to be sort of like trading value in a fiat or currency related modality. Now let's talk about the evolvable token type. So in this particular sample, what we were representing is a house. So up here in the contracts module, you'll have the house state, and every Corda state has an associated contract. But let's go into the house state first so I can explain what the differences are and what's going on with an evolvable token type. So as we remember, the primary concern or the value or the proposition of an evolvable token type is that we can change the definition of a particular token decoupled from the holding or ownership of that particular token at a time. So if you're a Corda faithful and you know how generally CorDapps work in the more central case, if we were to say take a fixed token and just extend that token type class, add some properties, pass it along as that instantiation, like as that token type, if we change the definition to be able to propagate that change to all of the holders out in the wild or on your Corda network, would be massively verbose, because we would have to basically create transactions to update the current representation or the current ledger state of that definition. But what they've done with the evolvable token type is we've said, okay, let's have something that is a state itself. So this will be on ledger as a definition. And then instead of passing this around, what we will do is we will create a pointer to the most recent valid definition, encapsulate that pointer basically as a token type that we can build our token, whether fungible or non-fungible, and then any holder of that token can move, can trade, can redeem, etc. Like basically agnostic of worrying about, like basically agnostic of kind of having to deal with any changes, because the pointer will resolve to this current change when needed. So let's talk about this. To instantiate this, you're extending an evolvable token type, and that's going to basically enforce you to have some minimal properties that you'll have to implement and override. I'm going to point out the most important ones here. So we have basically, like the regular token type, we have a fraction digit. This is 0, and the reason it's 0 is because this will be issued as a non-fungible token. So that means there's going to be no fractional digit or sort of like splitting or merging over time. And in that case, we want this fraction digits to be 0. The second important thing is the linear ID. So even though there might be multiple tokens in the wild that are basically pointing to this definition, so for instance, if this was a fungible token, etc., and we had 4 holders and they were all sharing stake in this house, they would all be kind of resolving, or the obligation would be to this single house. So this single house will only evolve in a linear manner. So anytime a change is made, that previous state will be marked as historic or invalid, and the new definition will take place. So that's why this linear ID is here. These maintainers are the ones that have the authority, or are the basically designated parties which are able to create new evolutions of this. So the list of maintainers are the ones that you can have access to, like in the sense that these can change this. So there's a difference and distinction between an issuer and a maintainer. So the issuer is the one that is holding the obligation. So if I issue this, when you go to redeem, or say you want to destroy this car, or leave the Corda network, or you want to basically call it in the physical world, or the base representation, then that's claim is against the issuer. But a maintainer, you can think of as like, who would need the authority, or who would have the motivation to change certain properties of this house. And this could be obviously the issuer also, but it could be a construction company. So if a construction company wanted to add another bedroom, they would be in the list of maintainers because they would be allowed to modify that. Or it could be something like an inspection agency or a government authority. So this is who you might want to maintain your evolvable token type. So this can be sort of like transferred, even though it represents a house. You can think about it in any sort of use case you might own. If you wanted to have something like an airplane manufacturing company, or if you wanted to have something like tracking clinical trials in a medical context, you can have, say, like extends patient, like clinical patient extends evolvable token type, and you can add things that might change over time, such as like the condition of the patient, etc. And the maintainers could be the researchers on that project, or the doctors involved, etc. So this, what you're learning today, is really extendable and malleable to any sort of use case. So up here, following Corda patterning, like I said, any state will have a representing contract. And for evolvable token contracts, you'll see that is an extension. So it's extending evolvable token contract and allowing you to add additional checks given different operations. And the reason that this is extending and not just purely implementing the contract is because, like I said, the value of the tokens SDK is that they're handling the maintenance and operation of your tokenized solution through abstractions and through their APIs. So if you were doing a basic state or a basic CorDapp, in your contract, you would have things like, okay, if I'm creating this or issuing this, I want no inputs. I want like one output. If you are, trading fiat currency and you have 100 rupees or $100, when you send 50 to one party, you want to make sure that there's change back. There's another 50 that comes back to you. But all of these boilerplate operations and things that we had to do manually in our own implementation before, Tokens SDK will automatically handle that. So those base cases are in this extension here. And then these are just additional things also that you would want to do if you wanted to, like enforce certain signers and et cetera, et cetera. So that's kind of like the state and contract aspect of it, of an evolvable token state. And now let's look at the flow. And two things are happening here. In this one particular flow, there's going to be a create and an issue. So remember, still going with that pattern, create, issue, and then operations you can do, such as move and redeem, etc. So for creating, we aren't using that fixed token pattern, like where we just created a token type and grabbed our own instance of it, whether that's Anthony token or whatever. Now we are creating an instance of our evolvable token type state. So here you can see what we did is, first we generated a UUID. This is just sort of like what you need for the argument that will instantiate the linear ID. Remember I was talking about that linear chain. So this is going to be something completely unique. But what's really cool here and important is the instantiation of our custom type. So we're creating it, and this is allowing us to have an instance of a definition that we can apply and commit to our ledger. The second line here, or this line with the transaction state, It looks new because when you're doing traditional CorDapps, you're not always using this particular instantiation, but it's something that the transaction builder, if you're used to that, this is a wrapper that takes place. And basically, in this case, we're going to tie our house state to the notary, which will be assigned initially to always monitor for uniqueness, consensus, etc. So this notary and house state coupling happens through the transaction state. And again, if you grab these samples off the repo after the workshop, you'll always be able to follow this flow and it'll sync in really quickly. Now, something unique here is we have to run this subflow called create evolvable tokens. And so what's happening here is that we need to commit this definition to our ledger and be able to operate on it in terms of using it to issue tokens. So the create evolvable tokens subflow will basically handle all that in one line. So that transaction state that we coupled the notary with the house state, you just pass it into create evolvable tokens. And this is going to basically streamline the process and create this, this instance on your ledger. So now that's kind of like where the differences end and the similarities and streamlining begins again. So kind of going back to this step. We're on this right one here where we're going to do it with a house though. So we have our house token type, we're going to issue it and we're going to say it's non-fungible. So we do this again with the builder, but this time we're using the non-fungible builder. And the non-fungible builder, we're going to define or like specify the token type. And here's where it gets back to that difference that I was talking about. So this difference, I just explained, I'm going to explain it again, and it was also in the diagram that Chris showed. So we'll be trying to reiterate this because it's really important to understand. So with the evolvable token type, what I need to do is I have my state, but I still need a token type, I still need a token type instance to operate throughout the SDK's different flows. And I need that layer of abstraction to allow holders to, move and redeem, etc. So what I did is in this definition of the house state, we are creating a pointer. And don't get too caught up with this because this is just boilerplate stuff that you can implement on your own evolvable token state. But this pointer, what it's going to allow us to do is to, instead of passing the definition, we're passing a pointer to the currently valid definition at any time. So when a maintainer changes the mileage, or when a construction worker adds that new bedroom, even though you're holding this pointer from before the change happened, you are going to be having ownership of the current state of that house. So this pointer is actually of type, token type, and it allows it to seamlessly interact with all of our operations. So that's what's going on there. Then we have the regular issued by, held by, and you'll notice we have no amounts because this is non-fungible. And then simply execute the building function at the end of your statement here. So then we're getting our non-fungible token, and using our non-fungible token is just the same. We can now call a subflow which will issue it. So it's very similar, slight differences between the two. And now I'm going to go into another cool project, which is also from our samples repo. And I'll show you this in action. Like we're going to demo it and we'll show it through the Node Explorer. So let me switch projects here. And actually, just before I dive into this, are there any questions? Is anybody kind of feeling comfortable? Are you feeling lost? Are there any questions or things that are burning in your mind up to this point? Because I'll go through a little bit more and it'll illustrate a lot more visually what's happening here. Okay, it seems like everybody is following along fine. So let's talk about seeing this in action and what's happening. This is a similar project, also using the house analogy or a house as a digital asset. But I'm using this one because it's kind of bringing together in one demonstration the two concepts that we just went over. So in the last one, we showed that we created a fungible fixed token, like a fungible fiat representation, and then we created a non-fungible evolvable token type. What this project is doing is it's taking an evolvable token type of the house and it's creating it in a fungible manner. So it's saying that this house is not a single owner. This house is something that we can trade on maybe a secondary market or something. So opening up liquidity to digital assets and allowing different parties to participate and have ownership in different stakes on this particular asset. So this particular flow class has a few different flows and operations which we might want to do, and they're broken up. So the first one here, we have the create, which is that create, and where we're going to instantiate an instance of our fungible house token state, and then call that subflow that we just talked about, which was create evolvable tokens. So now after executing this flow, we're going to have that definition. But after having the definition, we have to issue it and actually create this token pointer and then assign a holder, assign an amount, etc. So this is what's happening in the issuing stage. To call this, we have certain parameters that we ask for. We're saying like, okay, what particular definition are you talking about? We're going to map those with a symbol. And then what's the quantity? And then who's the initial holder? Who's going to hold this? So over here, because we've broken it into two stages, the creation and the issuance are separate, you'll see that the first step that we have to accomplish is to grab that definition from our ledger, from our vault. So what we do is we use the service hub. And what's happening here is we're querying all of the fungible house token states, and then we're filtering on the symbol. So if I create a state of a house, I can say Anthony's house as a symbol, or I could say like Chris's house. And then what I want to do is, I want to issue obviously only one of them at a time. So this is where I would filter and receive a state ref, which will allow me to now do things with this particular state. So here we've taken the state ref and encapsulated it, let our Java virtual machine know that it's of type fungible house token state. And then again, fungible token builder, same old, same old. So we pass in the token type, which is a pointer here. We issue as ourselves. So we say we're the issuer. We have our holder, which we define in the parameter, could be any counterparty, the amount that we're going to be issuing, and then we build it. And then the subflow issue tokens. So I hope this is starting to settle in as the flow becomes like step, step, step. Now, after issuing, okay, what if we want to move? What if we're that counterparty that just received the issuance and we want to say, oh, I want to give, 20 of my tokens, of my house tokens to my best friend. This is where they would call out or basically execute the, sorry, I wanted to do not disturb. Okay, this is where they would execute the move house token flow. And to do this, same sort of patterning. Here we're just grabbing the state. So we're grabbing something that we have the definition. So we're going to say, okay, this is the thing that we want to operate and move. And then we will create an amount. So amount is just a wrapper that's going to couple a quantity to a definition. So the amount will couple how much we're discussing or logically operating on with the definition, and the definition being that pointer again. So we're saying that this is of type this definition. Now that we have an amount, this is all we need to execute a move. So again, all of the backend stuff that's happening in terms of okay, does this person, do you actually have this amount available? Where on the network is this holder residing? Like what's their IP address? How do we send a network message? What do we do with the change, et cetera, et cetera, et cetera. This is all abstracted away, and we can execute so simply with just a single call. Now, if you want to go more advanced, you can dive into these particular subflows and see how they're broken up. And there's actually more advanced operations, like related to delivery versus payments, et cetera, which utilize sort of the inbuilt functionality. So you're able to move up and down in complexity with the tokens SDK, but at the basic level of getting things done, it's very, very synchronous and easy to do. So finally, this is just a responder, which is kind of like following in terms of like now somebody is sending me. So this is the receiver. This would auto execute on their node and call a responding subflow. I'm going to show the list of flows that are available in the tokens SDK after the code session. But the basic patterning will be that any operation or flow available in token SDK as an initiator will have a responder that has a countering name plus handler. So that's kind of how you'll be able to recognize them. And then finally, okay, I don't know why it's grayed out, but this is a redemption. So the redemption is where we are saying, let's take this off ledger, let's burn it. It's now going to be no longer represented in the pattern in the ecosystem of our network. So for this would be actually calling in that obligation on the issuer. So for instance, if I bought this house, it was created and issued on Ledger. I'm holding the token, traded around to like 10 different friends and buddies as we, like mortgaged, remortgaged, all these different things. And then finally, at the end of the day, whoever is holding, whether it be like a majority stake or whether it being the full fungibility of that house, if they burnt that house down, or if they decided they're gonna, like take it out of reality and create a super mall or whatever, then this is where we can say, like, whatever case, we can redeem it. So we can say it's going off, whatever agreements with the issuers will now be settled. So there's different ways to do it, but redemption is basically calling in the obligation, or it could be like a burn. In the financial area, it could be representing assets, trades, values, and then saying like, we're no longer dealing with this issuer. We want to call back the obligation and take our money elsewhere or whatever. So this can be a redemption. So this is sort of how it goes in terms of the major operations. Remember, we're always creating, issuing, and then in the transfer phase, we can like move, we can redeem in terms of actually working with these tokens. So now I'm going to launch what's called the Node Explorer, and we'll be able to see these in action, and I'll be pointing out which flow is happening as we go through. So what I have here is a terminal instance in this directory. Instructions for how to do this is all in the readmes of the different samples. So if you go into our repositories and see something you like, instructions of how to execute and do different things is there. So I've already done what's called the deploying of nodes. So I have a mock network on my computer already, which I can run through the console. I'm going to basically go build node run nodes, and this is going to spawn up 4 different parties on a Corda network. Once I have these up, I'll be connecting to them with the Node Explorer, where we can visually interact and see what's happening. But just before that, let's talk about who's going to be on our network. So remember, any Corda network, to do transactions and evolve states, we're going to need a notary. So we have a notary defined here. Who else do we need? We need a seller, because we're going to be selling this house, doing something with it. And then we need some counterparties. So besides the seller, we'll have a buyer, and let's also throw in a friend. So now we have these nodes up. What I'll do is I'll point you out to this RPC connection address. You can see that on this particular party, it's 1006, and this is the seller. So let's go into the Node Explorer. I have Node Explorer. This is downloadable at the repo. I will post the repo for you right after the session, and then you can download this and play with it. But basically what I'm doing is saying that this particular node exists locally on my network. I'm logging into 1006, and the username is default user1 test. Now I can connect to this mock network. So here, blah, 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 dashboard, node information, but what I'm interested in is running flows. So let's go to transactions, and you'll see that I haven't done anything yet. The seller is basically a newbie, a new party on this network, and they're going to want to do something now. So let's do a new transaction. Here you'll see the different flows there's a helper flow here as well, which is get token balance, which we'll be able to use to just quickly query the vault from a flow. But we also have the vault view in the Node Explorer, so we will use that as well. So remember that first flow that I showed was creating. So creating this house token flow, which involves instantiating an initial definition for this particular house and then placing it on ledger. Let's think of a house that we could create. Anthony's pad. So I'm going to create Anthony's pad. This will be the identifier, which will always be used in our flows to basically decide that this is the definition I'm looking for when I'm doing something like an issuance or move, etc. And the valuation, how much is this house worth? Well, I'm not super rich, so let's say that this house is worth 10,000, whatever that is. Now I'm going to execute it. This is all happening on my node, and I've created a transaction. And now you can see that there's a definition of this. So this exists. So this is now on ledger with the different properties that I put in that pop-up or interstitial, which I just did. But now this is not enough. So now I have a fungible house token state, which extends an evolvable token state, but I have no tokens. This is just saying that the house is now defined as something in the Corda ecosystem. But I need to create these tokens based on this. So what I can do is run another transaction, which will issue it. So now that I have it, I can issue it. I'm going to put in Anthony's pad. I'm going to say, let's split this and give a quantity of, say, 200 to a buyer. So this buyer I've just created the most amazing pad. I'm going to sell it to the buyer. So I'll execute this. And successful. So remember what happened in terms of our code. Let's go there quickly. When I just did that operation, it jumped right into here, into the call, and started doing this sequence. And this sequence was grabbing that definition from my ledger, creating a fungible token with the parameters that I passed, the holder and the quantity, and saying that this is represented by the pointer to this definition. So now, back on this transaction explorer, we can see that the transaction just took place. But what's going to be really interesting to see is if we have that token, we do not have a token that we're holding in our vault. It's actually going to be the buyer that has it. So we've issued this particular transaction, but the current holder of this is going to be the buyer. So I'm going to log into the buyer. And the buyer is addressed at 1009. So let's just log out of this. User one test. So very bad security here, but we're in to the buyer. So the buyer, you see I have this fungible token. And now you see also that I have this fungible token in here, which is amount 200 and is unconsumed. I can now spend this. I can now operate on this. So I can move it to somebody else. I can redeem it, et cetera, et cetera. So what would a buyer want to do? Maybe they wanted to share or split that with friends. So what I can do is run a transaction to do that. So I'll do a new transaction and let's move it. So the symbol was Anthony's pad. The holder will be my friend now. So I'm saying, okay, friend, here, have some of this. Let's split this equally. So I'll give you 100. Executing this, a transaction takes place and it's successful. And we can see that here we have a UTXO model where I initially started with 200 amount of this token, and it's created two outputs, one of them being a 100 amount of tokens to my friend, and then the remaining change coming back to me. And remember from the code, this was also synchronous and very simplified. because all of that boilerplate splitting, etc., will be happening on the back end through the provided functionality of the tokens SDK. So it's very, very easy and simple to do your use cases. I want to just kind of like bring this around and say that the important thing to grasp from this session is how you can extend this to particular use cases or functionality that you might envision for your CorDapp. So this doesn't have to be a house. It doesn't have to be a car. It can be anything like a piece of art. It can be something like tokenizing energy claims on a network, or interacting with like maybe hydro, or putting tokenization of different any sort of obligation. It can even be like a service use case or whatnot. And the idea is anytime that you want to represent something in a manner that can be easily traded, redeemed, issued, etc. This is where the tokens SDK really shows its power, because most of it will be abstracted away from you and handled simply through the flow framework. So I did want to show redemption, but my sample has the redeem code. Honestly, I don't know. I just pulled this from the repository this morning, so I'm not sure why it's like this. But take this from the repository, uncomment this, and try your redeem. And it's just basically swapping one simple flow to redeem fungible tokens. And if you have any problems, slack.corda.net, you can reach out directly to me or ask anybody there, where we have a lot of experts. So I'm going to quickly wrap this up just by showing a summary of what's capable, what the potential of Tokens SDK is, and where you can go next to continue your journey and find resources to move even further with your projects. So let me open up the slides. What's here is the Token SDK built-in subflows provided for you. So the thing is, tokens are not unique or new to Corda. Tokens always existed. If you went through a bootcamp, say 2 years ago on Corda, and you created a simple state, maybe representing a value or representing a fixed asset or a digital asset, that was actually a token, but you were implementing everything yourself. So you were coding the logic to issue, you're coding the contract constraints to check if a move is valid. You were doing all these things manually. But in today's day and age, so many of this boilerplate is basically transferable to many use cases, and you want your CorDapp to have extensibility and interoperability with many different applications and use cases. So what the Tokens SDK does is it takes the most pertinent functionality and simply provides the easiest and most functionally streamlined APIs for you to do this. So every one of these is available through the Tokens SDK. Like I said, if there's an initiator, there will be a handler, and they will be named as such. So it's very easy to navigate. And you have the create, issue, move, redeem. And in the case of evolvable token types with changing properties, you have the update evolvable token. So the update will go and make sure that this is a valid maintainer that you've specified, that this is somebody who's able to do it. It will create a new state for that token, and it'll update the distribution list. So all of the holders will be able to point to this new evolution. So potential use cases, this is just kind of reiterating what we discussed. When do you use evolvable? When do you use fixed? And then types of assets. So you could represent not just off-ledger assets or real-world assets, but you could also do on-ledger assets, etc. So it's very, very flexible. I would struggle to find a use case that I couldn't tokenize. If you want to challenge me, just ping me, reach out, say, could you tokenize this? And I'll get back to you. Definitely, I'll have it. Try it yourself. We have these versions and sample. We have the stuff that I went over in Kotlin and Java. We have many other samples in our sample repositories. So head there. There's always READMEs describing the functionality and how you can test and operate that sample, so you're never lost. The ones that are very interesting and pertinent are listed here. There's a fungible house token, which I went over. Stock paid dividend is really cool. So it's representing stocks. And then there's also a bike market, which allows you to have different components of a bicycle and create, move, and redeem operations on those components with suppliers and buyers, etc. Other resources, which are not just token specific, but we have a training site. There's a whole Corda library section, which has tokens as well as accounts there, which is another extension to Corda, which you'd be very interested in. They interop seamlessly. We have slack.corda.net, join in there, docs.corda.net, where you'll find your API docs and key concepts and also small code snippets and all of the theory. The GitHub repository will link to all of the different things that we have been producing internally and making available for developers to leverage. Email us, devrel3, and then Twitter. So that's it for the session. If there's any questions, we'll stick around for 1 or 2 minutes and you can type them in the chat. Otherwise, I'll pass it to Chris. You can give some final words and of wisdom, and then we can sign off.
Fantastic. Thank you so much for the presentation, Anthony. That was great. So I hope that everyone feels ready to get started building their own token implementation. If at any point you feel lost or you get stuck, feel free to reach out to us. You can find us on the Slack. There will always be someone from developer relations there who can help you out, as well as a lot of community members who are also willing to jump in whenever necessary. So I hope you enjoyed, and I wish you all a great rest of the day. Take care.